Hi, in this video we will take a look at a couple of proofs with the conjunction rule. This is Logic Self-Taught with Dr. Phi. In this video we will learn to do proofs with the conjunction rule. We will do 3 such proofs. They're given to you here. Try to do them on your own and then keep watching as you need. Let's recap. We need to be given 2 propositions, however complex, but they need to stand on their own lines, and then we are allowed to add their conjunction in whatever order the conjuncts occur. We just keep track of the order in which we conjoined the propositions when we justify the line. Before we begin our first proof, let's see how to set it up. This is the argument we want to show to be valid in a proof. And we basically begin by drawing the derivation line. We then list all the premises. We number each line, each premise, and we justify them as premises. We then use the premise line to close off our premises. We are not allowed to add any more premises to the proof. Finally, we pencil in the conclusion at the bottom of the proof. This is optional, but it's useful to do that. Note, however, that the conclusion is not a line in the proof yet. It's not justified. It doesn't have a line number. It's there just to remind us what we want to get. There are 2 main strategies of doing proofs: working forward and working backward. The working forward strategy involves your applying the rules available to see what comes out. But the danger is that you may go astray. After all, the point of the proof is to try to reach the conclusion. So at the beginning, I disadvise the use of the working forward strategy. We'll mostly use the working backward strategy, which involves thinking about how to obtain what we want. We'll use a scrap piece of paper on which we'll pencil in sub-conclusions that we need to derive. So let's try to think here how we could obtain the proposition that we want. It's a conjunction, and we know a rule that allows us to infer a conjunction, the conjunction rule, which requires that we have each of the conjuncts on its own line. This means that we would need to have the first conjunct on its own line and the second conjunct on its own line. We already have the first conjunct on its own line on line 1. So we don't need to worry about it anymore. What we do not have is the second conjunct, B and C, and we need to try to get it. We will basically apply the conjunction rule to its conjuncts, that is, propositions B on line 2 and C on line 3. That's it. That's our plan, so let's carry it out. We apply the conjunction rule to propositions in line 2 and 3, remembering the order in which we apply the conjunction rule. Here we want B and C, not C and B. Now that we have derived the proposition in line 4, the conjunction, and given our first premise, we can obtain our conclusion, again by applying the conjunction rule. We remember the order in which we want the conjuncts, and we also need to embrace the complex conjunct in parentheses. But that's it. That's the conclusion we wanted. We completed the proof. We have 3 premises, a conjunction and 2 simple propositions, and a rather complex looking conclusion. We work in the same way. We have our scrap paper, and now we need to think of how to get the big conjunction. We will need both conjuncts on their own lines. We will note that we already have the first conjunct. We have the conjunction DNA, so we don't have to worry about it anymore. But we still need the second conjunct. It's a conjunction. We will apply the conjunction rule again to get it. We will need its conjuncts. So we will need C and B on its own line and B and C on its own line. But now it should be clear to you that we can apply the conjunction rule to get both. We will apply the conjunction rule to premises 2 and 3. We are ready to go. We apply the conjunction rule to premise 3 and 2 first, and to premise 2 and 3 second, or we could do it in the other order, doesn't matter. And then we conjoin these two propositions, remembering to embrace the complex propositions, the conjunctions here, in parentheses. The final step is simply to apply the conjunction rule once again, remembering to embrace the complex propositions in parentheses. Now, in this case, the conclusion is so complex that it actually bears careful checking that we have all the propositions in the right order, that we have all the connectives in the right order, that we have all the parentheses in the right order. Proposition wanted and the one that you obtained must be identical. But here they are, so we are done. We have 3 simple propositions again, A, B, and C, and a conjunction that we want. But we proceed as we did before. We plan things out first. To obtain the big conjunction, we need its conjuncts on their own lines. Now we will be able to get the second conjunct, B and C, easily from lines 2 and 3, so we can let it rest for now. But in order to obtain the first conjunct, we will need its complex conjunct first. That's A and C. B we already have on line 2, so we can forget about it. These are our subgoals here. We can obtain A and C by conjunction, B and C by conjunction as well. Let's proceed. We apply the conjunction rule to premise 1 and premise 3 and obtain the first subgoal, A and C. We apply the conjunction rule to premise 2 and premise 3 to obtain B and C, our second subgoal. And now we can apply the conjunction rule to line 4 and line 2. Remember to place the parentheses around the complex conjunct. What remains is the final application of the conjunction rule to line 6 and line 5. Bear in mind, we want the conjuncts to occur in a certain order, so be sure you force yourself to apply the conjunction rule in this way. We embrace the complex propositions in parentheses, and we are almost done. Given that this is such a complex proposition, we again double-check that everything is as it should be, that the proposition wanted and the proposition we derived are identical. They are here, so we are done. One thing that students sometimes ask about is whether we could have proceeded in a different order. And the answer is, well, that depends. Sometimes yes, sometimes no. In general, you can change the order in which you proceed, provided that at each step, the propositions that you need to apply this step are already available in the proof. Let's look at an example. This is our last proof. If you look at steps 4 and 5, they don't depend on one another. So we could have well exchanged their order. We could have proceeded differently. We could have arrived at B and C first and then A and C second. Frequently, when you change the order of steps, other things change. If you look at step 6 in the first proof, you'll see that in arriving at step 6, we depend on the conjunction A and C in line 4. In the second proof, we obtain the same proposition in step 6. We still rely on A and C, but now A and C occurs in line 5. So that's the line that needs to be cited. And the same is true for the other proposition. So don't try to mechanically change the steps after you've carried the proof out. Always double check that everything else in your proof tracks the change. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.